All right, let's jump right in. We're going to talk about one of the biggest headaches in the tech world today. How in the world do you deal with the absolute chaos of real-time data? And more importantly, we're going to look at this really cool approach called serverless that's completely changing the game. So let's get into it. I want you to picture this. Your app's just cruising along, maybe 10 people using it. And then bam, something goes viral. In the span of a single second, you suddenly have 10,000 users all trying to hit your system at once. Is it ready? Can it handle that? You know, this isn't some far-off hypothetical. This is the new reality of real-time data, and it's the exact problem we're going to tackle. So first things first, let's really get a handle on the problem itself. I like to call it the real-time data tsunami. We are just getting hit with these massive, totally unpredictable waves of information from everywhere. IoT sensors, clicks on a website, social media interactions, logs from our own applications, you name it. And the way we used to build things, our traditional infrastructure just can't keep its head above water. Yeah, the old way of doing things, it's kind of like owning a giant restaurant and deciding to keep it fully staffed 24/7. You've got every chef, every waiter, every dishwasher on the clock, just in case a massive tour bus pulls up. But here's the thing. Most of the time, that bus never comes. The restaurant is empty, and you are just burning cash, paying for all those people to stand around. It's just wildly inefficient. So if the old way is this super expensive, usually empty restaurant, what's the better way? Well, this is where we bring in serverless architecture. It's a totally different way of thinking, a modern solution built from the ground up for this modern, unpredictable problem. So what the heck is it really? Put simply, it's a way to run your code only when you need it, in response to some kind of event, like, say, a new piece of data showing up. The two key phrases here are event-driven and no infrastructure management. That second one is huge. It means developers can stop worrying about managing servers and patching operating systems, and instead focus 100% on writing the actual code that makes their app cool. And when you put the two models side by side, wow, the difference is just night and day. The old way, servers are always on, which means you pay for them even when they're doing nothing. And scaling up, it's a slow, manual nightmare. But with the new serverless way, it's a total game changer. Functions only run when an event happens. You only pay for the literal milliseconds they're executing. And scaling, it's completely automatic and instantaneous. All that operational headache, it just vanishes. Okay, so that's the big picture. But let's zoom in. What actually happens on a micro level? To really see the magic here, let's follow one single piece of data as it takes its little journey through a serverless system. It's this beautiful, elegant four-step dance. Step 1. An event happens. Let's say an IoT sensor out in a factory spits out a temperature reading. Step 2. That tiny piece of data immediately triggers a serverless function into existence. Step 3. The function's code runs. It might check if the temperature is in a valid range, maybe convert it from Celsius to Fahrenheit, and get it ready to be stored. And finally, step 4. The result is delivered. That processed data is now sitting safely in a database, ready for use. And the whole thing happens with virtually zero delay. So now take that tiny instant journey we just followed and multiply it by thousands or even millions of events happening all the time. When you do that, you really start to see the two incredible superpowers of serverless pop out. Insane automatic scaling and just massive cost savings. Hey, remember our question from the very beginning, that jump from 10 to 10,000 users in a single second? A serverless platform is built for exactly that kind of chaos. It doesn't even flinch. It just says, okay, you've got 10,000 events? No problem. And it spins up 10,000 separate parallel instances of that function to handle every single one, automatically. No human has to lift a finger. Let's look at a social media app. You know how a post can just explode? Every single like, every share, every comment is its own separate event. Instead of one poor server trying to handle all that and getting totally overwhelmed, a serverless architecture can spin up a dedicated, isolated function for every single interaction. That's how an app stays snappy and responsive, even when it's under an insane, unpredictable load. Or how about a ride-sharing app? Think about it. It's taken in a constant stream of GPS data from thousands of drivers at once. That's a fire hose of information. So you use services like AWS Kinesis to act as a buffer, kind of like a traffic cop for data, making sure nothing gets lost. Then, serverless functions can just pluck each location update from that stream, one by one, and process them to calculate those real-time arrival estimates we all depend on. And one more, real-time analytics dashboards. As every single person clicks around a website, each click can be an event. A serverless function can grab it, process it, add it to some running totals, and then use something like a WebSocket to instantly push an update to a live dashboard. This means a business can see exactly what's happening, as it's happening, and even get automatic alerts the very second something weird is detected. Okay, so we've looked at the problem, the solution, and some real-world examples. Let's zoom back out for a second and really lock in the most important things you need to remember here. Look, it's an incredibly powerful tool, but it's always important to have a balanced view. The advantages are just huge: automatic scaling, paying only for what you use, and letting developers focus on writing code. But there are some things to consider. The big one people talk about is the cold start. It's a tiny delay the very first time a function runs after a while. But honestly, it's a solved problem. We have techniques like provisioned concurrency, which is basically a fancy way of saying you can tell the platform to keep a few functions warm and ready to go at all times. When you boil it all down, it's really about this powerful combination of three things: event triggers, instantly scalable resources, and super granular pay-for-what-you-use billing. Together, they radically simplify the process of building these complex, responsive systems because they remove the biggest bottleneck we've always had: managing the infrastructure. And really, that leaves us with one last, pretty exciting thought. For decades, what we could build has been limited by the sheer complexity of managing servers. Now that serverless is tearing down that barrier, the real question becomes, what new, incredible real-time